In the vast expanse of space, the solar system unfolds like a grand cosmic ballet, a swirling dance of planets, moons, asteroids, and comets choreographed by gravity and time. From the blazing heat of Mercury, through the vibrant blues and greens of Earth, out past the frozen worlds of the Kuiper Belt, this celestial symphony carries the story of our cosmic neighborhood. Yet, in this immense cosmic arena, there remain places unexplored, secrets unrevealed. The outer solar system, with its ice giants and shadowy satellites, holds some of the final frontiers for human discovery. Among these distant realms is Uranus, an enigmatic planet, often overshadowed by its larger siblings Jupiter and Saturn, yet no less mysterious or compelling. Now, astronomers have uncovered a new piece in Uranus's cosmic puzzle, a tiny new moon, designated S/2025U1, a faint, fleeting whisper of rock and ice orbiting silently in the planet's gravitational embrace. This discovery reminds us that even on the edge of the solar system, in the cold, dim reaches of space, the universe continues to reveal itself, slowly, patiently, inexorably. Uranus is a world unlike any other. Its axis is tilted dramatically, almost rolling along its orbit like a spinning top knocked askew. This extreme axial tilt, nearly 98 degrees, means that for decades at a time, one pole basks in continuous sunlight while the other is plunged into unending darkness. Scientists believe this peculiar tilt is the result of a colossal impact early in the solar system's history, a collision so violent it forever changed Uranus's spin and altered its moon's orbits. Its atmosphere is a calm blue-green canvas, painted by methane gas absorbing red wavelengths of light, concealing turbulent storms and mysterious cloud formations below. But much about Uranus remains unknown. Its internal structure, magnetic fields, and complex system of rings and moons have only been glimpsed briefly, most notably by Voyager 2's fleeting flyby in 1986. Since then, astronomers have relied on Earth-based telescopes and sophisticated imaging techniques to deepen our understanding, pushing the boundaries of what can be seen across billions of kilometers. The search for new moons orbiting distant planets is a careful and painstaking endeavor. At nearly 3 billion kilometers from Earth, Uranus's faint satellites are tiny beacons lost in a sea of stars and cosmic dust. Astronomers use powerful telescopes equipped with state-of-the-art sensors to capture long exposures, sometimes hours or even days, to gather enough light from these dim objects. By taking multiple images over time, scientists identify moving points of light shifting in concert with Uranus's orbit, the hallmark of a newly discovered moon. The discovery of S/2025U1 is the result of this meticulous work, sifting through vast amounts of data, eliminating false positives, and confirming the moon's presence through repeated observations. It stands as a testament to human ingenuity, perseverance, and the relentless desire to uncover the unknown. Though S/2025U1 is tiny, perhaps only a few kilometers across, it holds outsized importance in planetary science. Small moons like this are cosmic time capsules, relics from a primordial era when the solar system was young and chaotic. They can reveal clues about the processes that shaped their parent planets, whether through collisions, captures, or gradual accretion of debris. Studying these small satellites allows scientists to reconstruct the violent history of Uranus's moon system and the broader outer solar system. They help us understand how planets interact with their surroundings, how ring systems evolve, and how gravitational forces sculpt the architecture of planetary systems. Each newly found moon enriches our cosmic narrative, adding detail and depth to the grand story of planetary formation. The detection of S/2025U1 relies on decades of technological progress. Modern observatories combine ultra-sensitive imaging with powerful computing algorithms capable of identifying faint, moving objects. These telescopes, such as the Subaru telescope in Hawaii or the European Southern Observatory's Very Large Telescope, peer deep into the darkness, collecting photons faintly reflected from icy worlds billions of kilometers away. The images collected are processed with machine learning and automated software that can differentiate moving satellites from stars, cosmic rays, or instrument noise. This synergy of human expertise and cutting-edge technology allows astronomers to push the limits of detection further than ever before. With future telescopes like the James Webb Space Telescope and the Extremely Large Telescope coming online, our capacity to explore these distant realms will increase dramatically. Voyager 2's flyby in 1986 gave humanity its first close look at Uranus, revealing a complex, fascinating world, but only for a few fleeting hours. Since then, Uranus has remained largely unvisited, a mysterious blue-green orb slowly orbiting the Sun without a dedicated mission to study it up close. The discovery of S/2025U1 adds new urgency to the call for a return mission, an orbiter that can map the planet's atmosphere, probe its magnetic field, and investigate its moons in exquisite detail. Such a mission would answer fundamental questions about the formation of ice giants and the dynamics of their satellites. It would not only deepen our understanding of Uranus itself, but also provide critical insight into the countless ice giant exoplanets orbiting distant stars across our galaxy. The discovery of a small moon around Uranus is more than a scientific achievement. It is a reflection of humanity's insatiable curiosity and our yearning to understand our place in the cosmos. Each tiny world we uncover reminds us of the vastness and complexity of the universe. It challenges our perceptions of scale and significance, that even the smallest celestial bodies can have profound stories to tell. These discoveries inspire wonder, encouraging us to look beyond our earthly confines and imagine the cosmic forces shaping distant worlds. They connect us to the history of the universe itself, formed from the same primordial dust and energy that sparked life on Earth. The solar system is a dynamic, ever-changing environment, a place where new discoveries await at every turn. S/2025U1's presence, though subtle and quiet, is a beacon signaling that the story is far from over. As our technology advances and our missions venture further, the secrets of Uranus and its moons will continue to unravel. With every new moon discovered, with every orbit tracked, we deepen our understanding of the cosmic neighborhood that sustains us. This journey of exploration, marked by perseverance, innovation, and wonder, reminds us that the universe is an endless frontier, always inviting us to look upward, to seek, and to learn. In the stillness of space, where sunlight is weak and time flows slowly, S/2025U1 orbits quietly, a tiny world, part of a vast cosmic dance. Though unseen by the naked eye, it marks humanity's growing footprint in the exploration of our solar system. The journey continues toward the unknown, toward discovery, toward the ever-expanding horizon of knowledge. And as we gaze upward, we remember, every new world, no matter how small, enriches the tapestry of the cosmos. Every discovery brings us one step closer to understanding the universe and ourselves.